Industry, engineering, explained. This is where machines finally make sense. Imagine a motor running inside a refinery, surrounded by flammable gases, vapors, and chemicals. One tiny spark, and the entire plant could explode. Yet thousands of motors run safely every day in oil refineries, chemical plants, and gas terminals. How? They use something called an explosion-proof motor. But here's the surprising truth. Explosion-proof motors do not prevent explosions. Instead, they are designed to contain them. Today we'll explore the fascinating engineering and physics behind these machines, and why they are critical for industrial safety. Inside every electric motor, there are multiple sources of sparks and heat. Electrical switching, brush sparks, and even friction between moving parts. Normally this is harmless. But in specialized industries, the air may contain flammable gases or dust particles like methane or hydrogen. If the concentration reaches the explosive limit, even a tiny spark can lead to a massive industrial disaster. That's why we need a specialized solution. The motor is designed to sacrifice itself to protect the entire plant. This brings us to the most critical technology, the science of flame paths. When a gas explodes inside, high pressure and hot flames try to escape. Engineers designed precision metal joints called flame paths to stop them. As hot gases pass through these extremely narrow gaps, the metal surfaces absorb the heat, cooling the gas below the ignition temperature. By the time the gases exit the motor, they are no longer hot enough to ignite the surrounding atmosphere. It's thermodynamics in action. But cooling the gas isn't enough. The housing itself must handle incredible pressure, often reaching 10 to 15 bar instantly during a blast. This is why these motors use thick cast iron housings and heavy-duty bolts. The casing acts like a pressure vessel, trapping the explosion inside. Even without sparks, hot surfaces can be dangerous. Every gas has an auto-ignition temperature. Gasoline vapors, for example, ignite at just 280 degrees Celsius. Explosion-proof motors are rated by temperature class, from T1 to T6. A lower class rating means the motor is safer for highly sensitive explosive gases. Factories are divided into hazardous zones based on risk. Using the wrong motor in the wrong zone can be catastrophic. The IEC and ATEX systems define Zone 0 for constant risk, Zone 1 for likely risk, and Zone 2 for abnormal conditions. In the US, the NEC system uses classes, Class 1 for gases, Class 2 for dust, and Class 3 for fibers. Selection must be precise. You'll find these motors everywhere. Safety is paramount. From massive offshore oil rigs and refineries to LNG terminals. They are the backbone of chemical plants and paint factories where flammable vapors are a daily reality. Even grain silos and pharmaceutical plants use them to prevent dust explosions, which can be just as deadly as gas. Designing these motors is an extreme engineering challenge. Manufacturers must pass rigorous certifications like ATEX, IEC, and UL. These tests simulate real explosions inside the motor to ensure the enclosure holds. Only then is the motor approved for hazardous use. This complexity makes them heavier and more expensive than standard motors. But in these environments, the cost of failure is simply too high. To summarize, they contain explosions, cool escaping gases, withstand massive pressure, and control surface heat, all through brilliant mechanical design. These motors are the silent guardians of industrial plants worldwide, working every second to keep everything and everyone safe. Next time you see a refinery or a chemical plant, remember the physics at play. Engineering isn't just about making things work, it's about making things safe. Thank you for joining us at Simple Gyan. If you found this dive into industrial safety fascinating, subscribe for more engineering simplified. Stay safe and keep exploring the science behind the machines. I'll see you in the next one.